Okay, let's see how it's this capture working with our non-simulation growth geometry. Let's plug our tree here. Okay, and it looks like it's capture all geometry. Let's isolate to our trunk and see if our growth is working. Yeah, so you see our tree is growing and moving, but we need to do with our trunk something. So we have growth attribute per each branch, and it's growing from 0 to 1. So we should use this to change the geometry width, and we will do it next thing. So this is our trunk, this is our spine, and for each point we have the growth attribute from 0 to 1. So we will take a point on our geometry, find the closest point on the spine, on the surface point. It's not a point, it's just a surface, so we need the shortest distance. And we find this length, and we'll multiply this length by this growth attribute on the near point. And then we will lerp actual position with this founded position. And this point will move in this direction when we will use a lerp function. Let's do it. Let's create a point triangle. And plug our spine here. So let's create an integer prim variable vector uv, and I will use x, y, z distance to find the corresponding primitive number and uv position to be 1. Our position prim and uv. Oops. Okay, so now we have a primitive and uv on the spine, and we can import so we can find the position on the spine. And let's create a vector pos equal prim uv 1, our position prim and uv. So now we have the corresponding position on the spine, so we found this point, this position of this point. Next, we need to find the nearest growth attribute. We'll use near point for it. Here, equal near point 1 at P, and load our growth position. Float growth equal point 1 our growth attribute and point number pt. And now our position equal lerp, so it's blend between two vectors, our position and current position, and we use a growth attribute, growth Now let's see. Okay. Let's see here. Let's check. And we have growth here. Yes. And this changes. Let's see what happened. XYZ, prim UV, prim UV. Position near point. Oh, I made a mistake, sorry. Okay. Now, yeah, now it's working, so it's moving. And if we check here, so it start change the thickness accordingly. But it changed thickness because this growth attribute common for all branch. So we need to use a gradient to make a tip. So basically, if you remember in volume 2, when we create a growth based on gradient, so we have a gradient per each branch from 0 to 1, and the growth increasing from 0 to 1. So we can apply this lerp function only if this growth attribute less than gradient. And else it will be 0. The position will be, sorry, let's see. So if our growth attribute less than gradient on the point, we use a lerp, and it will be like this. But on over the top, this position will be exactly this position, and it's create a tip. So it's more looks like a growth. Let's copy this, and it will be gradient. So we need to find a gradient on that point, and we need to type if our growth attribute less or equal gradient, we apply a lerp, and else our position equal false. And let's check. Yeah, and it's working in opposite direction. Let's see. Oh, it should be opposite. So if our growth, yeah, because the gradient is constant, less or equal. Sorry about that. Yeah, now we have a tip. And let's see how it works on all three. Alright, looks like everything working. Let's jump the latest frame. Okay, yeah, it looks great. Everything is working, our growth is working, and then simulation we are capturing well